So deep time is the temporal scale of Earth itself, the scale at which glaciers advance, oceans open and close, and entire ecosystems emerge and disappear. It is time measured not in centuries, but in millions, even billions of years. Yet deep time is also something more than a geological measurement. As Noah Herringman reminds us, deep time is also an imaginative problem. How to grasp processes that exceed human perception. So let me start out with a small personal experience of that problem. Because for many years I have traveled regularly to Athens, in Greece, that is. And each time I arrived, I would do the same thing. I would walk toward the Acropolis and look up at the Parthenon. The temple is about 2,500 years old, and for a long time that number felt almost incomprehensible to me. Standing there, one senses the weight of antiquity. It seems astonishing that something built by human hands could survive for so long. But one year something changed. I remember the moment very clearly because I looked up again at the same ruins, but the feeling was different. Suddenly I did not experience those millennia as a vast temporal distance. Instead, I found myself thinking, 3,000 years is actually not very long at all. The Acropolis had not changed. What had changed was my sense of time. Instead of measuring time in historical units, centuries or millennia, I had begun to think in geological terms. 3,000 years is a long time for empires, but it is almost nothing for a glacier, and it is nothing for the ocean. That shift in temporal perspective is what we call deep time. The concept of deep time originally emerged within geology. It refers to the immense temporal scales required to explain the formation of the Earth, the slow deposition of sediments, which we will hear about later, the movement of tectonic plates, the advance and retreat of glaciers. And Noah Herringman reminds us that deep time is not only a scientific concept, but also an imaginative one. Long before geology became an established discipline, writers, explorers, and philosophers were already trying to imagine temporal horizons that exceeded recorded history. Deep time in this sense is not simply a measurement of age, but a mode of imagination, a way of grasping processes that vastly exceed human experience. And today this concept has become especially important in discussions of the Anthropocene. As Jeremy Davis has argued, the Anthropocene confronts us with the unsettling realization that human actions now operate on geological scales. Burning fossil fuels releases carbon that has been stored underground for tens of millions of years. Plastic may remain in sediments for thousands of years. Nuclear waste may outlast entire civilizations. And in Davis's striking formulation, we are now living in the fissures between one epoch and another. But Davis also insists on something else that is often forgotten in discussions of climate change. The reason we should be concerned about global warming, he writes, is not that the Earth's climate was once perfectly stable and harmonious. On the contrary, the planet's atmosphere and climate have changed dramatically, many times before. These transformations often produced entirely new configurations of life, changes that, however successful in themselves, arrived like a conquering army to a fallen city, as he says. That is, for the organisms that had previously inhabited the planet. Seen from the perspective of deep time, environmental change is not exceptional. It is fundamental to Earth history. What is new is that humans have become part of those planetary processes. The ocean plays a crucial role in making this temporal perspective visible. More than 70% of the Earth's surface is ocean, and much of the planet's geological history is recorded not on land but in marine sediments. The seabed functions as a vast stratigraphic archive in which the traces of past climates, extinctions, and evolutionary transformations are preserved. At the same time, the ocean carries a powerful symbolic dimension. As Elizabeth de Lovery has argued, scientific discourse positions the sea as both origin and destiny. Origin because life on Earth emerged from the ocean, and destiny because rising sea levels, perhaps the most visible sign of planetary change, connect the melting of the polar regions with coastlines around the world, producing a new awareness of planetary scale, interconnectedness, and an even bluer planet. The ocean is therefore not only a geographical space but also a temporal medium, linking planetary origin with planetary destiny, deep past with deep future. Glaciers, rivers, and oceans are not separate systems but different temporal states of water moving through the Earth system. When we speak about glaciers, we are therefore also speaking about the ocean. The Anthropocene confronts us with a paradox. Humans now influence planetary processes that previously unfolded only in deep time. Literature sometimes helps us to imagine this shift in temporal scale. And a striking literary example of this deep time imagination can be found in the Nobel Prize-winning Danish writer Johannes V. Jensen, particularly in the novel The Glacier from 1908. The glacier unfolds during the Pleistocene ice ages and depicts a world shaped by glacial advance and retreat. The novel moves between periods of freezing and thaw, portraying a landscape in which ice, water, and climate continually reshape the conditions of life. In one passage, Jensen describes the end of a glacial phase. The great thaw sparkled in the eye of the sun over the north. The ice sheet was in rapid retreat. This was not to be wondered at, for the weather that had come on was enough to melt mountains, as it is today, by the way. Thunder showers and warm rain gushed down incessantly, and between them the sun broke through, so smilingly powerful, so full of hope. At first glance, this may appear as a simple scene of climatic change, but within the larger narrative of the novel, it represents something much larger. The glacier is not merely scenery, it is a planetary force. Across centuries and millennia, it advances, crushes landscapes, redirects rivers, and eventually retreats again. Human beings, pre-human beings, appear within this process only briefly, adapting to environmental conditions that they neither control nor fully master. What Jensen captures here is the fundamental paradox of deep time. Processes that appear almost invisible within a human lifetime can nonetheless transform entire continents. The glacier melts, rivers form, and eventually the water returns to the sea. In this sense, Jensen's glacier is also part of the ocean's history. What we witness in the novel is not simply weather, but planetary history in motion. Seen from this perspective, literature performs an important function in the Anthropocene thinking. Scientific discourse can measure geological processes, but literature provides narrative forms through which humans begin to perceive them. By stretching temporal horizons and compressing millennia into scenes or images, literature can render deep time and the planetary histories recorded in ice and ocean momentarily perceptible. In that sense, works like The Glacier do something remarkable. They place human history within a far longer story shaped by glaciers, oceans, and planetary water cycles. If Herringman shows that deep time must be imagined, and Davies that we now inhabit it in the Anthropocene, then Jensen's The Glacier reveals how literature makes that immense temporal horizon visible and sensed. Jensen's mythic narrative thus helps counteract what Marcia Bjørnerud has called our society's temporal illiteracy. Deep time shows us that human history is not the measure of the Earth. It is only a thin layer, a very thin layer in a far longer planetary history of ice and ocean. Thank you.